Imagine you're in this high-stakes corporate command center. A crisis hits, and you need to switch the main 4K display to a live feed, and the screen just goes black for 3 agonizing seconds while the
Ugh.
system buffers.
Oh, yeah, that is the worst.
Right. In that kind of environment, 3 seconds feels like an absolute lifetime. So today, we're doing a deep dive into the specialized hardware that actually makes that delay disappear entirely.
It's a really incredible piece of tech.
It is. We're looking at the Atlona AT-OMNI-111 OmniStream single-channel networked AV encoder. And our mission for you today is to decode exactly how this device manages massive 4K video networks without any lag or bottlenecks. It sounds a bit like an audio textbook, I know, but it's really the secret to seamless visual experiences.
Yeah, and the journey of that video signal, it basically starts with raw speed. I mean, we are looking at a device capable of switching between massive video streams up to 4K resolution at 60 frames per second in less than a half second.
Wait, less than a half second?
Yeah, less than a half second. It's incredibly fast. Well, here's where it gets really interesting. Because it's not just abruptly cutting a wire to make that switch, right?
Oh, not at all.
It's almost more like a club DJ, flawlessly beat matching 2 tracks. The system actively aligns the differing resolutions and frame rates in the background so you never actually perceive the transition.
Exactly. And what's fascinating here is why that fraction of a second is the ultimate metric for success.
Why is it so crucial?
Well, think about a massive sports bar or a university lecture hall or that command center we just mentioned. Any lag completely breaks the illusion of continuity.
Oh, sure.
So the system doesn't force the display to go black and resync. It just simply holds the visual continuity.
Okay, let's unpack this for a second. If you have a network that is constantly firing these huge 4K files instantly, I mean, if you keep adding heavy 4K streams, doesn't the network eventually choke like a massive traffic jam?
Well, yeah, they absolutely would if the device were sending raw, full-frame data every single millisecond. Right, because standard 10 gigabit uplinks between network switches are fast, but eventually the pipes burst.
Exactly. But to prevent the network from bursting, the encoder relies on something called the VCX codec. And a codec is basically just the software engine that compresses and decompresses the video data.
Okay, so it squishes the files down.
Well, yes, but the VCX doesn't just blindly squeeze the files. It actually looks at what is physically changing frame by frame and only transmits that new changing information.
Oh, wow. So, like, if a newscaster is sitting at a static desk on a 4K feed, the encoder isn't resending the heavy image of the entire desk 60 times a second.
Right, exactly.
It's only sending the movement of the newscaster's lips.
You nailed it. That intelligent compression is what drastically cuts down the bandwidth required. And the VCX codec was expressly designed for system expansion and scalability, which solves that exact traffic jam problem.
That is so smart.
Yeah, it allows you to continually add more 4K and 1080p streams to the same network without overwhelming those 10 gigabit uplinks. The flow of data just remains incredibly efficient.
Okay, so the signal is generated instantly, compressed intelligently, and it flies through the network. But now it hits the destination, right? The AT-OMNI-121 decoder, which is actually tasked with putting the video on a screen.
Right, the decoder.
And the specs say this decoder can ingest up to 4 separate streams from the OMNI-111 encoders and display them all simultaneously in a multi-view format.
4 streams, yeah.
But wait, sending 4 full 4K streams to a single screen sounds like an absolute nightmare for the decoder. Wouldn't it just melt trying to process all that incoming data at once?
Oh, it would crash instantly if it had to do all the heavy lifting.
Right, so how does it survive?
Well, the true aha moment of this whole ecosystem is the distribution of labor. The OMNI 111 encoder doesn't just send the main heavy 4K stream. It simultaneously pre-formats a dedicated low-bandwidth proxy stream that is specifically tailored for that multi-view window processing.
I see. So the heavy lifting actually happens before the video ever reaches the screen.
Exactly.
The encoder is serving up this highly optimized lightweight stream right to the multi-view window, saving the decoder from crashing.
Yeah, it completely shifts how we think about moving data.
It really does.
Yeah.
So just to wrap up the journey for you today, we've got ultra-fast switching that mimics a DJ beat matching, highly scalable streaming through the VCX codec's frame-by-frame efficiency, and brilliant distribution of labor for flawless 4-screen multi-views.
Yeah, and this leaves us with a final, rather provocative thought to ponder.
Lay it on us.
if enterprise hardware can juggle multiple uncompressed 4K streams in half a second over a network today without missing a single beat, I mean, how long until this level of instantaneous, zero-latency video processing becomes the baseline expectation for every single screen you interact with?
It's coming fast.
Mm-hmm.
So the next time you're staring at a buffering wheel on your phone, just remember the underlying mechanics to eliminate that delay entirely are already working perfectly behind the scenes.